Okay, so here is 1.3, midpoint and distance. We are going to be able to find midpoint and distance at the end of this and use them in problem solving. So this we're going to do in class tomorrow, so just skip over this slide. You can think about these questions if you want to, but we'll be talking about them in class. Here, the essential question is, how are the midpoint and length of a segment on the coordinate plane determined? Well, midpoint of a segment is the point that divides the segment into two congruent segments, two equal parts, okay? Divides it in half. A midpoint formula is x plus x divided by 2 and y plus y divided by 2. And of course I'm going to put the little 2, 1 here, and we'll talk about that in class. Now let's find midpoint. So midpoint of AP. So I'm going to write the formula again. So x plus x divided by 2 and y plus y divided by 2. And my x's are -3 plus 4. And my y's are 2 plus -2 divided by 2. And I get 1/2. 2 plus -2 is 0. 0 divided by 2 is 0. Okay. So it talks down here common error. Finding the midpoint is like finding the average. Okay. This is the average. We'll talk about this a little more in class tomorrow. So be sure to add the coordinates though. Everything we usually are doing is subtraction. A lot of it is subtraction. We need to add in this case. Let's see. So now I want you to stop this video and try these two on your own, and then come back and check your answers. Okay, so hopefully you got those answers, -3.5, and then -1.85, and -5.4. If not, we will ask me in class and we will go over those. Okay, so now this is the big part of this lesson and the kind of the harder part. What are the coordinates of the point 3/5 away from A to B? So we want 3/5 of the distance. Okay, so the first thing we know we got to do is find the distance between the x's and the y's. Okay, so the distance between my x's, 3 and 13, is 10. The distance between my y's, -4 and 11, is 15. And I'm going to multiply that by 3/5, because we want 3/5 of that distance, which would be 6 and 9. All right, so now this is still distance. It's not the point. So we need to think about our first point. Our first point, A, is at 3, -4, and we're moving towards B, which is at 13, 11. Right? So we want 3/4. So I need to move 6 from 3, and I need to move 9 parts of the distance from the y. So my point would be at 9, 5. Now I'm not doing any more of these in the video. I will do more of these, talk about these here in class tomorrow, because this is the hardest part of this section. I'm also not going to talk anything about this one. All right, the copy didn't do so well. It's a little dark. But it says a pitcher throws a ball to a batter who hits the ball to the shortstop. If it travels in a straight line, what's the total distance traveled? So if we think about where the pitcher's at, right there at 5, 5. The batter's at 0, 0. And the shortstop is at 5, 10. So the distance between these two guys, the distance between my x plus my distance between the y's, is going to give me 50, which is 7.1. And then the distance between the batter and the shortstop is 5, oops, sorry about that, 5 squared plus 10 squared, which is about 11.2. So I have a total distance of 18.3. And down here it says, excuse me, 1 unit equals 9 feet. So I'm going to multiply that by 9, and I get 164.7. Okay. And then the next one, how far does the shortstop need to throw the ball to reach the first baseman? So you try this. Remember the shortstop is at 5'10", and the first baseman, if you can't see it, is at 10'0". So find the distance between these, and then come back and check your answer. Okay, so hopefully you got 11.2, and remember it is 9 feet for each little block. So that's why I'm multiplying it by 9. Midpoint and distance on the coordinate plane. Remember midpoint, x plus x divided by 2, and y plus y divided by 2, and distance looks like this. And then it wants us to find the endpoints. It wants us to find midpoint. And when the endpoints are -3, 4, and 1, 7. Now, if I'm doing this, and I have a coordinate plane handy, I'm just going to count. So the distance between the x's is 3. Distance between the y's, I'm sorry, 4. The distance between the y's is 3. So if I do this, I'm going to end up with 5. And I need you to realize that this is a 3, 4, 5 triangle. And we're going to come across those a lot. It's a special triangle. They're called Pythagorean triples. And a lot of times if you see a leg of 3 and a leg of 4, you should automatically just know that the hypotenuse is 5. And let's see. I think the rest of this we're doing in class. Yes. So there you have it, our first video.